Hello, everyone. Can you hear me well? I think we can get started then. Okay, and the topic of my talk today is authentication provider, and specifically implementing Oauth 2.0 with your own hands. And before I continue, let me ask you two questions. Who uses Oauth in their systems currently? Yeah, I'm assuming like many people do. Now, who can explain fully how it works? That's what I expected, because I had my own poll. I asked several people, many people, and like the results were pretty much the same. Okay, let's get started. I mean, I already have a self-promotion slide over here, but the only thing that I wanted to highlight over here is like, I'm not an expert, I'm just a conscious and competent in security, so take my content with a grain of salt, or a lot. Anyway, so why OAuth? Why I chose this specific technology? Well, the thing is that OAuth defines 4 distinct roles of the authorization flow. And what it means is that these subsystems can live on separate server boxes, which means like it's perfectly compatible with distributed system architecture and like the proverbial microservices that are very popular these days. Another thing, like everyone uses it, like all services, all famous services provide the OAuth protocol implementation. And if you are about to build a mobile app for your system, you're probably going to use OAuth. You either implement it yourself or you use one of these services like Okta or Auth0 or something like that. So I think this is a good justification of why you should understand how it works. And one thing I noticed when I started researching how it works to like improve my understanding of it is like, I mean, as Radu said, accepted and familiar, I was like, hey, this sounds familiar. I mean, this has been done for centuries. This is a very old practice, and we simply put it on top of HTTP. That's it. And here's the proof. This is a thing from like 13th century. This is an actual access token that was used to signify certain privileges, and things like that were used in Mongol Empire, in China, and Persia, many other places. So this is the familiar thing. And this is not a cookie. This is actually Kublai Khan granting an access token to Marco Polo. You probably heard of the guy. He was a famous Italian merchant and traveler, and he actually mentions access tokens from his travel to Mongol Empire. Now, next thing is let's set some things straight. So it's often, I often hear that people confuse these two terms, authorization and authentication, and they are not the same. They have the same prefix, but they aren't the same. So authorization is about granting access or denying access. It's about access policy for a resource. Whereas authentication is about the identity of the user, is proving or disproving that the user is who they claim they are. So this is a very important distinction, and when you hear OAuth, it's actually about authorization, and OpenID Connect is about authentication or user identity. But to confuse you more, like it's all the same thing. It's a stack. So the thing is that OpenID Connect is actually implemented on top of the OAuth. It's just the OAuth was so well adopted that the guys who wanted to do login with service X, they just used the existing protocol and they put the identity over authorization. Okay, and I wanted my talk to be practical, so I'm actually going to show you some code, and we'll start implementing the 4 roles of the OAuth one by one. And one of them is a resource server. It provides resources. And here's the spec. So I've used their spec to kind of describe what's the behavior of the system should be. And you see that resource is protected by default, but when you submit a bearer token, resource becomes available. When the token expires, resource becomes unavailable again. Or if your scope doesn't match, again, it becomes unavailable. And this is just more meat to the spec. So unavailable resource, when you supply a token, you usually supply it in the headers of in an HTTP header. And yeah, if the token expired, you get a forbidden status. And the same thing when you try to access housing resource, but the scope of the access token is food. And here's the implementation. It's very primitive, but it's valid. So to signify the resource, I simply returned like a 200 status from my endpoint. And you can see that on the lines 10 to 20, this is actually the resource service access with access token, how it's implemented. And yeah, we can actually dive deeper. And this is usually how an access token looks like. We need to make sure that it's not expired and the scope is valid. And that's it. Next thing, resource owner. So resource owner is the user of the system. And again, I just used RSpec to describe the behavior of the system. And I don't want to go too deep into this. It's just we need some way to let users in, out, and things like that. And because I was using Rails, I just used the device gem that I recommend you using, and I don't want to even go deep into like registering users and letting them sign in and sign out. The next component to the OAuth are client applications. And these are applications that are requesting access to protected resources on behalf of the resource owner, which is the user. Sorry for the white background. Again, so here we are registering a client application. You can see that the authorization provider is the Mongol Empire. Then the user of the system is Kublai Khan. And we register a client application called Marco Polo Caravan because Kublai Khan is going to grant access token to Marco Polo so that Marco Polo and his people can use the resources from Mongol Empire. Next thing, you can see that when I create a client application, I get two random strings, consumer key and consumer secret. So consumer key is like the login of a client application. And it is public. You can share it with the web. Client secret is hidden. So this value is supposed to only be known by the authorization provider and the server that's authorizing, that's granting authorization code and access tokens. And we kind of have a bit of a problem here because the thing is that in these days, we build mobile apps and we build single-page apps, and they don't always have the server-side component. And client-side component, like browsers and mobile apps, are considered insecure. They are called front-end channels, and they are considered insecure. So we have a bit of a problem with the secret, which is supposed to live only on the server side. There's an answer to it. It's called Pixie. I really like this name because, you know, you kind of start thinking about the fairy tales, you know, pixie dust. So it's very easy to remember. What it means is it's a proof key for code exchange. It's an extension of the authorization code flow, which makes sure that you don't get into the authorization code injection attack. Like you protect your system from the authorization code injection attack. And it actually allows to fix the problem with the client secret because you kind of don't really need to use the secret anymore. And here's the ugly diagram of how a typical OAuth flow works with a mobile device. So we're having an authorization provider, and our Marco Polo application sends an authorized request. In response, the authorization provider sends an authorization code back to the application, back to the device, back to the system. So this code doesn't grant access to any resources. It only grants access to getting an access token. And this is what the next thing, which is done by the mobile application. So Marco Polo Caravan sends the token request to the authorization provider, and it gets a token grant. Now, the problem is that on the bottom of this diagram, you can see that mobile app registers custom URL schemes. In this case, it's mpolo://. The thing is, these custom URL schemes are not regulated. You can register any custom URL scheme. You can create a mobile app and you can call it like Apple : / or Google : / whatever. So the thing is that anyone can register any custom URL schemes, and here's what can happen. You can have another application installed on your mobile phone which will use the same URL scheme that your legit app uses, and you kind of get into this problem where gang of robbers can intercept the token request. And Pixie solves this problem. So it introduces a concept of code verifier, which kind of blocks the authorization code injection, authorization code interception attacks. Injection attack is a different thing. Okay, now let's look at how we can implement the flow with Pixie in actual code. So here's the setup of the fake authorization code exchange. So these are the givens. We have a user, which is the resource owner. We have a client application. We have a scope that we want to request, right? We want access to housing, food, and concubines. And you can see that on the line number 11, the Pixie stuff starts. Basically, we have the code verifier, which is an absolutely random string, which is created by the client application. That code verifier is later transformed into code challenge. Again, this happens on the client application. And this secret code challenge string is sent in the authorization query. So again, code verifier is only known by the client application. Code challenge is sent to the authorization provider. Then usually what happens, okay, we talked about that. Usually what happens, you get a prompt. It's like, okay, some application wants to access some resources on your behalf. Do you grant access? Blah, 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 whatever. And that's what we do. And the resource owner enters their credentials, their client credentials, and they confirm that they do grant the access. What the authorization provider does, it sends a redirect. And the redirect contains the code and the state. State is another security technique, but it's about code injection attacks. I don't have the time to explain it, but I can answer any questions if you have after the talk or in the hall. Next, so the client application receives the authorization code on behalf of the resource owner, and now they submit a token request to the authorization provider. And now you can see on the line number 45, the client app submits the code verifier value, which was secret to anyone except the client application until this moment. And this what actually lets the authorization provider kind of, decide, okay, this is a valid token request, and I can actually grant a token, which will later grant access to protected resources. So this is Pixie, and it's very important if you're building a mobile apps. And let's look at the code interception attack. So the first step is the same. It's like we go to the authorization prompt, we grant everything, and then this redirects gets to the callback URL of the bad guys. But the bad guys won't never know the code verifier value, so they won't be able to include it in the second request, which is the token request. And they don't, and well, they get the error. And here's the very primitive implementation. Here's how authorization endpoint looks like. Here's the view of it. You kind of show the requested scopes, and when you confirm the prompt, you kind of get to the authorization confirmation endpoint, and here's what happens. We basically create an authorization code, attach a user to it, we remember the scope, we remember the client application, and we simply redirect back to the callback that we know from the client application. Now, the second step happens this way. Again, we find the client application from the params, and we actually generate an access token by exchanging the authorization code. And let's look into this, and here's how it happens. Again, this is my code, very primitive, but it's valid. So now the authorization provider uses the code verifier value and creates the challenge value from it using the same algorithm that the client application did, because they know the algorithm, they just don't know the source value. And we can actually find the authorization code from our persistent storage, your relational database or whatever. And we simply grant the access token, assuming that the authorization code is usable, which means it's not expired and it hasn't been used already. And yeah, that's pretty much it. This was the authorization. Now let's talk authentication. As I said, authentication is about proving user identity. So what you need to do, you simply add a few more scope values to the authorize endpoint. And the scope values are usually OpenID, profile, and email. And then when you respond to the second step, to the token request, you include the ID token, and the ID token allows to access the user info endpoint, or you can actually use JOT tokens, where you don't need to actually call anyone anymore, because JOT tokens, they include the values in themselves. And here's what you need to change in the previous implementation. So the exchange happens like this, right? Okay, if we find that the requested scope included OpenID, we create an ID token and we return two tokens. We return an access token and an ID token. And again, very simple primitive implementation of an ID token is just a JOT token where you have a headers section, you have the payload section, and you actually have to sign it with a secret signature, which is only known to the identity provider. So it can be an SHA 256 signature that you store securely in your secret registry, and you just respond with this JSON Web Token. And the nice thing about JSON Web Tokens is that the client application don't need to make any more requests. They can simply read the values that you can see on the lines number 20 and 21. So they can tell who the user is. And that's pretty much it. And I just wanted to share the resources that I've been using when I was researching, and I really recommend you to watch Nate Barbettini, the guy from Okta. His talk about OAuth and OpenID in plain English. Very, very great resource, and then you can just go ahead and read how it works. Now, my colleague Roxana asked me to hijack this talk and actually share, not share, but award people who won nice things from Mixbook. And I will call 7 names. You guys will get awards from Mixbook. And Roxana, please join me on stage. While Roxana will be giving gifts, I can take questions. So the names are: number 1, Sergey Elvis. Name number 2, Marcel EBS. Name number 3, Alex 8W. Name number 4, Vyacheslav Technosoft. Name number 5, Vladimir Idusiter. Name number 6, Nikolai Issoft. Name number 7, Artem Amdaris. Okay, and while Roxana is awarding the gifts,
Alex AW is having a... okay, here you go.
Alex AW is number 3. So Sergey Elvis is getting an Apple Magic Keyboard. So everyone else gets a power bank.
I have a very important question. Are the power banks charged already? Because electricity is very expensive, and if they are charged, that's a great gift.
I think so.
Yeah,
I think
because
so.
you can do a lot of them. You can come home and charge everything.
Did you charge the power banks? I wouldn't rely on it. Okay, and now I'm actually done, and I can take questions about OAuth and OpenID if you have any.
Okay, like this. Hello, Vlad.
I think we have.
У нас тут есть еще, да, вот. Наш следующий спикер хочет выйти за подарком, а потом он выйдет еще раз. Потом выйди и зайди еще раз. Рано еще аплодировать, он не выступил. Давайте, guys, let's...
Сергей Элвис, мы зовем тебя, призываем.
Guys, let's applause to Vlad for the awesome presentation. Yeah. So thank you. Yeah, and gift for you. Just a second. Yeah, sorry. Where is the questions? I mixed everything. So if we have questions, yeah, please bring the microphone. We still have time for that.
Hello, Vlad. Is it working? Yes, it is working. Hello, Vlad. Thank you for your presentation about Oauth. I'm here.
Who am I talking to?
Left,
Okay.
Hey. Do you happen to know if there is a standard way to revoke a token using Oauth?
Yeah, usually the access tokens are supposed to be very short-lived, like 5 minutes, and that's how you revoke them. So they, by default, have a very short time to live. And that's how you make sure that even if they get stolen, like the time period when they can get abused is very short. And how you mitigate this, because like it's very secure. The problem with that is UX, right? User experience. And the problem with user experience is like, okay, I need to re-log in every 5 minutes, right? And they recommend using refresh tokens for that. So usually, like if you saw that I added an ID token to my access token, so usually you would also add a refresh token, which allows to get a new valid access tokens. Again, why is this better than like an access token which lives forever? Is that refresh token only allows to get an access token, right? And that's why it doesn't allow you to get any access to any protected resource. And then when you actually keep track of refresh tokens, you usually keep track of whether the token was used or not. So you saw that for authorization code, I recorded whether it was used or not. And the moment it becomes used, you kind of know, okay, no more token grants based on that authorization code. So the same thing you do for refresh tokens. You kind of, okay, if it was used twice, it means that it was stolen, and you invalidate the whole token family that's connected to the refresh token.
Okay, thank you. I'm asking in terms of, like, let's say we have a company that is using Auth provider.
Right.
And we want to fire an employee. And this is like a security reason, right?
Yes.
We want to make sure, we want to ensure that this person does not have access to our systems.
Right. So if you're using an identity provider or you're implementing that identity provider yourself, all these refresh tokens, authorization codes, and access tokens have some references to that user record. So you know the user record, and which means you can invalidate not the whole family of tokens, you can invalidate the whole tree of the tokens connected to that user. So that's how you do it. You need to keep track of the relations between refresh tokens, access tokens, authorization codes, and the resource owner which grants access. On the authorization provider, yeah, on that part of the system.
Guys, yeah, you can continue the discussion after.
Yes, yeah,
after that, yeah.
We have to take it.
Yeah, let's have.
Sorry,
guys, we'll have only one more question from the online stream, and the other question you may ask after the presentation.
Yes, it's Artyom who asks, what are the proper approaches to JWT invalidation for sign out, and do you blacklist tokens?
Well, again, the invalidation of the tokens happens because you specify how long the tokens lives, and that's it. So as long as it expires, you get signed out automatically. Does this answer the question, you think?
Yeah, yeah, the author asked it online, so yeah, we don't know. But anyway, we say thank you for your presentation. Thank you very much. Thank you.